Wrong page. I'm like, wait a minute, we're not doing Denali yet.
You can use it if you want.
Page 7. All right. So John, bad pain, bad things, ER, expensive. Doctor says, congratulations, because you're a smoker. You have a pneumothorax. That's what our case is about now. So, number 1, ENT should know what's a pneumothorax. Air where? In the chest. You have an air leak in the chest. Literally is what that means. So you're getting a hole somehow in that system. Well, why would that matter? Who cares if there's an air leak? Why would that screw things up?
Because it can't get bigger with the air in it.
Let's go back over here. For this to work, there has to be a difference in pressure. If there's a hole somewhere, the pressure doesn't change, right? The reason your tire goes flat is the inside and outside of the tire are the same pressure all the time. For your tire to work, the inside has to be more pressure than outside. So if I get a hole in my system, in my respiratory system, there can't be a pressure difference, therefore nothing will work. Does that make sense? So the system relies on a difference of pressure. So how could you get that? How could you get an air leak in your chest? Look at the second question as a clue. The pleura. I damaged my pleura. I damaged my pleural membranes. Remember, they're the ones that glue my lungs to my chest and hold it there. So now we got to figure out for question 2, what happens to the interpleural pressure if I put a hole in my pleura?
It doesn't have the high or the low.
That's right. I mean, essentially it becomes 0, right? So the pressure actually becomes 0. There is no longer a pressure in my pleura. It's not negative or positive, it just simply goes away, yes?
So it goes
It would go up. It would go from negative to positive, but it ends up 0. There is no longer a pressure inside my pleura, right? So once that happens, there's nothing to keep my lung stuck to my chest. So let me show you that. I have an animation to show you that. I have it somewhere. Where's it at? Yeah.
The lungs expand and contract within the chest cavity. The lungs are encased by 2 layers of tissue, similar to a fist that has been pushed into a balloon. The space between the layers, called the pleural cavity, is lubricated so that the lungs can slide comfortably across the chest wall. If air enters this space, it is referred to as a pneumothorax. One type of pneumothorax, called a traumatic pneumothorax, can be caused by injury to the chest. A blunt or penetrating...
So you're at the silo bar and get stabbed, right? Or your steering wheel goes through your chest because you don't have an airbag, right? Something punctures through my chest wall, just went through my pleural membranes into my lung. So if you think about it, they're all going to be the same pressure now, right? You have a hole between all those things. So when you move your chest, the pleura and the lung are not going to change pressure, right? They're not going to have a difference. Therefore, you now have an air leak in your chest, quote, you have a pneumothorax. And what would happen to your lung if this happened? You told me? They would collapse because there's nothing to keep my lung glued to my thorax. Right? So let's watch that.
chest injury can cause a small tear on the surface of the lung, allowing air to enter the pleural cavity and to become trapped. The pocket of air produces excessive pressure on the lung, causing it to collapse. A spontaneous pneumothorax occurs without injury as a result of certain lung diseases, such as asthma, emphysema, or COPD. Small air-filled sacs called blebs.
Okay. You got his kids must have made this up, right? That's what they call blebs. It's amazing, right? But those are blebs. It is a real word.
Form on the lungs. If the blebs rupture, they can release air into the pleural cavity. Pressure from the trapped air causes the lung to collapse. However, a spontaneous pneumothorax can also develop in a person with no obvious risk factors or disease. This condition is more common in smokers and in men between the ages of 20 and 40. Attention pneumothorax is a serious complication that can develop with any pneumothorax. If the pocket of trapped air cannot escape, it continues to grow. The increased pressure in the pleural cavity can push the heart and major blood vessels to the other side of the chest.
Yeah.
When this shift takes place, it causes a significant drop in blood pressure. This is a life-threatening condition that requires immediate medical attention.
You will die. Right, make sense? So you're getting an air leak, so now you're not really able to expand the lung properly. All right, so let's go back to our case study and work with that a little bit more. It was so quiet after that. Right? So let's look at John's symptoms. All right, so read the top sentence. What were his symptoms when this happened? What do you feel? Does he feel pain? Lots of pain in his chest. And what did you notice about his breathing rate later?
Increase.
Why would his breathing rate have to increase?
Trying to calm
Because
down.
it takes more air in.
Right, if you think about it, if you lose one lung, the other, you have to get more air more often to compensate, right? So he lost a lung. The lung collapsed. So everything your body would do is to deal with the fact you have half the air now going in and out of your body. Right? So your breathing rate would have to double. What does his heart rate do? Why would your heart rate have to go up? Compensate. I mean, it's going to take blood twice. I have to get twice the blood to your lung to have it deal with twice the air to give to the body, right? So he loses a lung, it collapses. Therefore, his body has to compensate by breathing faster, have the heart beat more often to compensate for the fact that only one lung is working. Right? Here's the one you want to look at: is the blood gas test. The doctor did a blood gas test. What gases are in the blood that they test? CO2 and O2. Tell me what CO2 would have done in John's case. It would have gone up. Tell me why it went up.
They can't get out.
You can't get it out, right? If the lungs aren't working, I can't exhale the CO2. So I expect it to be retained. So they call that a retaining. He would retain CO2 because he has one lung not working. What about his oxygen? It go down, right? Called a deficit. Because his lung isn't able to breathe the air in. So he can't exchange. Therefore, they don't trade places. Does that make sense? Okay. So now, let's figure out why smokers do that. So, tell me how smoking can make your lungs get holes in them. Causes blebs, yeah! Okay, but why would smoking give you a bleb? It doesn't even sound like English. Klingon. Kapla, bleb. Was it? Yes. To summarize, smoking will scar your lungs. So let's go back to 231. When you have scar tissue, how flexible is it?
Not very.
Okay, so now let's go back to our lungs over here. Every time I inhale, I have to expand and shrink my lung. So if they're scarring over, what do lungs do if you keep stretching them and they're stiff? They start to tear. What do we call those tears? Blebs. So the smoking doesn't burn your lungs, it makes them, they crack when they use them. If you don't believe this, take an old tire, leave it out in the sun all summer, then inflate it. It'll blow because the outside's getting stiff and it can't expand. Right? So as you smoke, the scarring of your lung makes it more likely to crack and create those blebs. There's then leak to the pleural cavity. Because you've lost those three things over there. Make sense? Yes?
So what is it exactly that's causing the scarring? Is it
That.
the drying out?
So since they're getting dry and getting scarred, they thicken, and that gets less flexible. So when you do inhale, they start to pop. They start to tear the outer alveolar surface.
So chemical stuff is not the cause
It
of
does
this,
affect it.
that's-
The desiccation,
Okay.
which is the last one, that's more likely for this than the toxin stuff.
Okay.
So smoking does body-wide stuff and then just direct
Okay.
destroy lung stuff. Yeah.
So are the blebs at the tear, or are they like scar tissue after there's a rip?
They're formally before the tear. So you get a bleb and then that makes the pneumothorax
Okay,
there.
so that's like the bubble.
It's like a cause, the bubble. Make sense? Okay, so let's do this one. They told him, don't go scuba diving. What's wrong with scuba diving? Pressure, right? So if you have a weak lung and you go scuba diving under pressure, what do you think the lung would likely do if you have blebs all over the place? Right, because remember it's a difference of pressure. So as I change the pressure, the lungs would overexpand or get constricted. So you don't want to put more pressure on the lungs. They're already weakened, right? Make sense? So don't become an astronaut if you have pneumothorax, right? Because you're going to cause more pressure changes than before. So tell me how they're going to fix this. How do doctors fix your pneumothorax?
Chest tube.
Chest tube. So tell me how that works. What are they trying to do with the chest tube?
Equalize pressure.
Equalize pressure. So what they're trying to do is 2 steps. Let's do that. Step number 1, they evacuate the air. They get that air that's trapped in there out. Ever watch MacGyver who put the straw on the person's chest? Am I the one that sees that episode? You're trying to get the air out, thoracocentesis, you're trying to get the air out of there. And then what they have to do after they get the air out? They have to plug the hole, and then they expand the lung. So 3 steps. So literally they evacuate the air, they patch the hole, and they repop the lung. If you work at Les Schwab, you do the same thing with an air tube. Right? You take the air out, you expand it, patch the hole. They do exactly the same for a lung. You have to keep the pressure difference there. Yes?
So they're trying to take the air away out of the
pleural space.
Okay.
You're trying to make the pleural back to negative. So you're evacuating the air, plugging the hole, and then expanding the lung. Okay. Make sense? So it's a problem getting the difference of pressure to occur within your chest. Make sense? Look at me silently. Okay, that's scary. Nod your heads there, that's good. Right, so question on pneumothorax, a problem with pressure differences. Yeah?
So, I don't know why I'm just having a hard time with the pressure idea.
Okay.
Is it kind of like blood vessels where smaller space gives higher pressure,
Yes.
expanded lower pressure? But with that, I guess the reason I understand blood vessels is because you have the same volume of blood in there, which makes sense that it would be
Right.
higher pressure when it's smaller.
Yeah.
But I don't know, I guess I feel like the air follows whatever it is.
That's what it does. By making your lungs bigger, the air has to go in to fill in that space. So you're drawing the air in by lowering the pressure momentarily, and then the air comes in and makes the pressure back to 0. That
Okay.
time delay, because you keep moving the lungs, air keeps constantly following. It's a fluid thing. You do the same thing in the hypodermic needle. When you pull the plunger back, the fluid has to go in to fill in that vacuum.
So it's just like a very quick, like instant.
Right, so that was one complete cycle of that. So next time you're shooting up your heroin, it's the same logic. You pull back on the plunger, push in the plunger, you pull it in, push it out. Same logic in a needle as it is in a water. Or bellows. Make sense? So now we got the air to go in and out. Now we have to figure out how do we get the gases to actually exchange. So if you remember, I need the gases not only to go in and out of my lungs, but in and out of the blood. So someone said the magic D word. What was that magic D word? Diffusion. So we're going to add one more picture to this about how do we get the gases to go. So, right here. Okay, so don't let the numbers kill you. All right. So for this class, you don't have to memorize all the numbers, okay? So don't. I'm not going to ask you what the 104 is. But you want to have a feel in your head for where the values are, because that helps you interpret some of the case studies we're going to do later, especially acid-base balance. So for your quiz, I'm not going to ask you 104 millimeters mercury. You have to get a feel for when you hear numbers, is that high or low, okay? So here's my air sacs. When I breathe in, the air has 104 millimeters mercury. This is a Dalton's Law chemistry thing. If you really want to know about that, I can teach you later. But for this class, for me, your chemist will hate me, we're going to say about 104 oxygens in your lungs, okay? You have 40 CO2s. It's completely chemically wrong, but it works, all right? So now, here comes the blood coming into your air sacs. How much oxygen's in the blood going to your air sacs? 40. How much was in the air sac?
40.
No. How much oxygen is in the air sac?
0.
104. There's 40 in my blood. There's 104 oxygens in my air sac. What does the fusion say? It's going to go in, high to low. So the oxygen will leave my air sacs after I inhale, and go directly into my bloodstream from high to low. So the blood will have 104 when it leaves my lungs by diffusion or magic. Right? You don't have to do anything. As long as the air gets to my air sac, it will go into my blood because the blood has less oxygen than my air sacs. Make sense? Okay, CO2 is supposed to come out, right? How much CO2 is in my blood?
45.
How much is in my air sac?
40.
Which one has more?
Blood.
Blood. So the CO2 will leave the blood to go into my air sacs when I exhale by diffusion. Right? So remember this thing from last term? Good. Move on. So here are my tissues. Where is that? Where are my tissues at? Everywhere. My foot, my rear, my brain, whatever. So my tissues have less than 40 oxygens. Why do they have such a low number? They're using it, right? ATP from Biology 112. They're using oxygen. So they're going to be really low. Look at my blood. It has 104. Which one has more oxygen? The blood. So the oxygen is going to go from my blood to my tissues. They have less than the blood by diffusion. So where's the CO2 at? Where's the most CO2? Why do they have so much CO2? Right, remember your cellular respiration. Oxygen goes in, CO2 comes out. So as I use up oxygen, I'm going to make lots of CO2, which is more than the blood has. And therefore, it's going to go into my blood, be taken away. So as long as my lungs are working and my air sacs are working, diffusion will drive the whole system. So you don't have to do anything other than have a beating heart for these systems to work. The oxygen will go down its gradient, the CO2 will go down its gradient the correct way. That kind of cool? All based on pressure differences. As long as there's more and less, the system will work. Right? I'm going to show you another picture here. This is from a journal biology book. Here's my air sac, here's my blood, blah, blah, diffusion. Right? Here's my blood, here's my tissue, blah, 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 diffusion. Because that's what's driving this process is more to less of the concentration gradients each time. All right? So let me show you an animation of that process, which is not this one, it's this one. Boom.
Fresh air entering the lungs carries oxygen to the alveoli. The amount of gas in air or of gas dissolved in a fluid can be expressed as partial pressure, which is measured in millimeters of mercury. The partial pressure of oxygen in the air within the alveoli is 104 millimeters of mercury. Carbon dioxide that enters the alveoli from the blood causes the carbon dioxide concentration in the air of the alveoli to be 40 millimeters of mercury. Carbon dioxide is continually removed from the alveoli as air is expired. Blood coming from the heart at the arterial ends of the pulmonary capillaries has a partial pressure of oxygen, or PO2, of 40 and a PCO2 of 45. Therefore, oxygen diffuses from the air in the alveoli into the blood, and carbon dioxide diffuses from the blood into the alveoli because of these differences in partial pressures.
More or less.
Oxygen and carbon dioxide diffuse until there is no difference in partial pressure in the air and the blood. At this point, there is no more net movement of O2 or CO2. Therefore, at the venous ends of the pulmonary capillaries, the PO2 in the blood and alveoli is 104, and the PCO2 in the blood and alveoli is 40. Some oxygen was removed from the blood to nourish lung tissue. Therefore, the PO2 in arterial blood leaving the heart is 95. Oxygen diffuses out of the arterial ends of tissue capillaries into the tissue fluid, then into the cells, and carbon dioxide diffuses out of the cells into the tissue fluid, then into the blood because of differences in partial pressures. At the venous ends of tissue capillaries, the PO2 in the blood is equal to the PO2 in the tissue fluid, and the PCO2 in the blood is equal to the PCO2 in the tissue fluid, resulting in no more net movement of O2 or CO2. The blood now carries the O2 and CO2 to the lungs. In the body, all of these exchanges occur simultaneously.
That's an important concept to keep in your mind, just like the heart. We draw it as though oxygen goes in, CO2 comes out, right? Remember, the blood's always going in a circle, so you're exchanging all the time. in both systems. So when you inhale, you end up with more oxygen in the air sac briefly. It diffuses more, but then when you stop and exhale, you still have exchange going on throughout the system because the blood's constantly moving. So it isn't that the oxygen goes in and then all the CO2 comes out. They're constantly being exchanged at the same time simultaneously. Right? So you have to kind of visualize, like in the heart, it's always happening all the time. All right? So I'm going to let this thing run. So you watch the red and the blue dots. They're constantly being exchanged from tissues and lung based upon the blood flow. Right? Make sense? So tell me why that old guy at the nursing home is packing that oxygen tank. Based upon what you just learned, there's a reason a doctor gives him supplemental oxygen under pressure. Can you guess?
Forces more oxygen.
How could it force more oxygen in?
It's pushing it rather than letting you suck it in.
How would that work? What's in the oxygen tank? Think about it. What's in the oxygen tank? Oxygen, higher concentration. So you're increasing the amount of oxygen up here, right? So there's more red dots up there, which says you're going to get more diffusion to here. So they're trying to up how much diffusion he can occur by ratcheting up the oxygen going in to force more to go into the tissues, right? That's the logic of that system is you're adding more, is that even English? An increased gradient by doing that. Make sense? That's the idea. It's all about more to less the whole way through. You okay with that? Because now we're going to do the chemistry part. We have to learn the chemistry of this exchange. We learned why. Now you got to do chemistry. You'll hate me now.